Maxim Plikus, better known as Max.
Max, morning, how are you?
Good morning.
I've got to tell you, there is not a bald man in the world who isn't chanting your name right now.
That's exciting to hear because we are excited about this research.
What I wouldn't give to have hair again, even though I haven't had it for 30 years, but there have been so many cures touted over the years, none of them have actually worked, and we've all had our heads licked by a cow. This one's looking good though, right?
I hope so. People tend to underestimate just how complicated hair is. And people think, well, how difficult can it be? Anything that Mother Nature created, it is complicated. It takes time to figure it out.
I've often thought if you water a dead plant, it can regrow. I'm no scientist, but I am a bald guy who has a comb, and I live in hope. Is it possible to regrow the hair?
Yeah, the plant analogy is kind of a good one. Upon common form of hair loss, your hair follicles, they don't disappear. They stem cells, they don't go away.
Right, so they're not dead then?
They dormant, and what they are doing, they idling, they waiting for a trigger molecules to activate them, and that's the culprit. The trigger molecules become deficient. You just don't have enough of them, and they're waiting and waiting and waiting.
They've been waiting on my head for a long time, longer than I've waited for a bus on a rainy day. Osteopontin. Tell me about this and how you've come to this conclusion that it's going to work.
What I tell to people is we had nature do the most important experiment. Nature created millions of people with hairy skin moles walking around this earth. It works millions of times, but nature left no notes. So to crack the code of a hairy mole, essentially what makes small hair become big and long, it was not very simple. But we went at it for about a decade. What we came out with this molecule called osteopontin. It's the molecule, it's a signaling molecule that potently tells hair stem cells to activate. And we think that's the essence of a hairy mole.
How far are we from this being on the shelf at the chemist?
Good question. We hope it's sooner rather than later. There is a clinical trial that's going to start this year. A company picked it up in California, and they're going to test it out in actual people. I have pretty good confidence it should work just because it already works in millions of people in the mole. The question is, will it work when applied onto the scalp?
You use micro needles similar to the ones used in Botox treatments, and then what's the turnaround time before you start buying Brill cream?
Molecules like this, they should work fairly quickly because once they awaken hair stem cells, hair starts to grow within weeks. Within weeks, one should see new hair sprouting. It doesn't take long.
I'm going to nominate you for the Nobel Peace Prize.
Let's not do that. There are bigger things out there.
No, there's not. Allow me to be the guinea in your pig. Any spare ones you got lying around, any vials, ship them over to me, and I'll tell you what, I'll go for it.
Okay, I got your number.
That sounds like a no to me, but anyway. Wow, that's exciting. And obviously, hair loss is an issue for women as well, not just men. But for men, it suffer from male pattern baldness. I'm telling you, I'm going to get this done.
Hello everyone, and welcome back to another ad hoc video. This is going to be a quick update on something that's been flying under the radar, and this is Amplifica and their hair loss treatment pipeline, rooted in research on hair skin moles, also known as hair nevi. Dr. Maxim Plikus is the researcher who helped discover the essential role of two molecules in hair growth from skin moles. These molecules are osteopontin and SCUB3, also known as SCUB3. In a recent interview, he announced that Amplifica, the quote-unquote California company he's associated with, which he mentions in the interview, he mentions that they will be moving forward with further clinical validation on their hair growth compound. And this is a big deal because we haven't heard news about Amplifica for a while, and it could be the case that they're, working on something. We might get some press reports coming out soon about maybe a new raise or something in that regard. And I want to make sure this community, the hair loss community, understands why, this AMP-303 or Amplifica's pipeline of osteopontin and SCUB3 analogs is a big deal. So, as always, it's good to review things about hair follicle biology. So, your hair follicle itself is a living, cycling mini organ that rebuilds itself from scratch every single cycle. And that process requires coordination between two fundamentally different cell types. This would be the epithelial stem cells, which form the structural body of the follicle and the hair fiber itself, and mesenchymal stem cells, which provide the instructional signals that tell the epithelial cells or epithelial stem cells what to do and when they should be doing it. Now, there's a crucial class of cells called dermal papilla cells, and these cells are central to the mesenchymal system. So that means they have their stem cell origins from the mesenchymal layer. Dermal papilla cells are a special class of fibroblasts, and fibroblasts in general are the primary connective tissue cells in the dermis that generate the extracellular matrix. In this matrix, you'll have things like collagen, elastin, along with polysaccharides, specifically glycosaminoglycans like hyaluronic acid, chondroitin sulfate, and herpin sulfate, just to name a few. And they are very crucial for skin structure, elasticity, and wound healing. The cluster of dermal papilla fibroblasts create a connective tissue structure that sits at the base of the follicle, and it is here that these cells release various growth factors and signaling molecules that activate epithelial stem cells to differentiate, which is essentially them transforming into new cells that would ultimately make up the hair follicle structure. They first will have to migrate from an area of the epithelial layer called the stem cell bulge area, and this is where those hair follicle stem cells are from. And then they organize themselves in the lower architecture of the hair follicle towards the dermal papilla fibroblast tissue structure. And when the anagen growth cycle is done, the dermal papilla signals this and essentially terminates growth, which leads to a dormancy period where the follicle essentially disintegrates only to regenerate again in another cycle. But without a healthy dermal papilla, none of this is going to happen correctly. And in androgenetic alopecia, and I've mentioned this in previous videos, the dermal papilla cells do not disappear, right? They're still there, but they gradually get weaker, they shrink, they miniaturize, and they lose their inductive capacity. The follicle gets progressively weaker in each cycle until it stalls entirely. And this pattern is not unique to DHT-driven hair loss. There's conditions like lichen planopilaris and also let's see if I can get this right, trichorhinophalangeal syndrome, I think that's how it's pronounced, where people have this sort of mutation with the TRPS protein where it actually creates an issue in their dermal papillas that, causes for them to have hair issues that are similar in pattern to androgenetic alopecia, at least when it comes to some variations of the mutation regarding the TRPS protein. Worth noting too, the erector pillae muscle physically connects the dermal papilla region to the hair follicle stem cell zone. And this is pretty important because if those regions are closer together in proximity, that means the dermal papilla has an easier time signaling to the hair follicle stem cells in the epithelial layer to, create the architecture of the hair follicle. So in early regeneration stages, we would actually want this to happen. But it is the case that in androgenetic alopecia, over time, the erector pillae muscle transforms. Something's wrong with the stem cells there. They transform and turn into fat cells or fat tissue. And with that being the case, it isn't, adequate enough to properly bring up the mesenchymal layer to actually communicate properly with the epithelial layer. So that's just one particular pathway where androgenetic alopecia kind of just destroys your hair regeneration capacity. But also I do want to note that the erector pillae muscle is supposed to regenerate itself, right? So in hair transplants, we commonly see that the erector pillae muscle is severed. So it's not necessarily that the severing of the erector pillae muscle results in permanent hair loss. It's more so that its transformation into fat, or it loses its sort of capacity to regenerate properly in androgenetic alopecia. That is what's leading to the improper hair growth, or it's contributing to it, right? So it's more so a symptom rather than a cause of permanent hair loss. And although I know this is a video about Amplifica, really it's also a discussion about Pelage and their compound PP405, which claims to activate hair follicle stem cells. Now, the underlying biology is real science and it's legitimate. So the Pelage team, they're doing some great things, but the mechanism of action of PP405 may be questionable, right? There might be some sort of hair growth properties to it that could translate into a clinical setting, but it might not be anything more beneficial than minoxidil. And the reason why I say this is because hair follicle stem cells do not disappear. So simply stimulating hair follicle stem cells and allowing them to proliferate, it's whatever, right? If those hair follicle stem cells cannot properly differentiate or transform into different cells that ultimately create the hair follicle organ itself, then, it's kind of like having fuel but not having a car to use the fuel with, or a generator rather, right? It's cool, I have all this fuel, but I need to do something with it. And when you look at the literature, it kind of points to that being the case. Dr. Luis Graza and Dr. George Cortielis, they published a paper showing that the bald scalps of people with androgenetic alopecia, they aren't missing hair follicle stem cells. The stem cell pool is largely intact, and what's actually missing is the intermediate progenitor cell population, so the cells that the stem cells are supposed to turn into. And it's the progenitor cells that are actually building the hair follicle and the hair fiber. So why are the progenitor cells absent? Well, it's probably because the dermal papilla cells responsible for signaling their generation are dysfunctional. And the biggest issue here is that Pelage is treating the epithelial side of a problem that originates from the mesenchymal side of things. So stimulating hair follicle stem cells when the dermal papilla cannot send proper inductive signals, really, again, it's like, I can give an example. Maybe like you're turning up the volume of a speaker that's not even plugged in, right? So imagine that. And you can kind of see Dr. Maxim Plikus talking about this in this particular interview. We played it at the beginning, so hopefully you guys heard the whole thing. But instead of, targeting the epithelial compartment, Amplifica goes directly to the source. Their pipeline targets the mesenchymal stem cell production and the signaling pathways governing dermal papilla health and regenerative function. AMP-303 is an osteopontin analog, and osteopontin was identified through Dr. Maxim Plikus' work on hairy nevi, where hair follicles were spontaneously entering robust, sustained growth from those moles. So by tracing that mechanism, it led to osteopontin as being a potential key driver of dermal papilla activation. And AMP-303 is essentially supposed to be designed as an analog that can mimic what osteopontin is doing. In fact, and I do have to remind people again, Amplifica actually had a first-in-human study where they used their AMP-303 compound in a single injection cycle over 6 months, which produced measurable increases in hair count. One injection in only 6 months, by the way, and this is real results in actual humans. So you're not dealing with a mice or, mouse studies or whatever the whole meme is, right? You're actually seeing this being clinically tested in human beings. You also have AMP-203 and AMP-506, which are additional potential osteopontin analogs with refined profiles. So hopefully Amplifica gets enough money to, study those, because they could possibly be more promising than AMP-303. We don't know yet. And we also have AMP-601, which is a SCUB3 analog targeting complementary pathways. Now, people ask, how are you able to figure out AMP-203 and AMP-506 and AMP-303 and AMP-601 are either SCUB3 or osteopontin? Well, there's a series of articles online that I'll put in the description which kind of paints the picture of that being the case. But however, together, they all suggest that Amplifica is building a multi-targeted approach to dermal papilla dysfunction rather than just betting on a single molecule. And the injectable delivery is worth addressing, right? So they're going in a sort of biologic kind of route, at least from what I can see in the AMP-303 first-in-human study. So they're dealing with glycoproteins. These are too large to penetrate the skin barrier. they're well above the quote-unquote 500 Dalton rule, so the injection is the logical route, right, in this particular case. Long-term, smaller molecules and mimetics could be engineered to hit the same exact targets through topical or maybe oral delivery. I don't know if they'd go the oral delivery route. Probably not. It might just be a topical or some kind of injection biological treatment that they will be looking at in the future. But that becomes more interesting as the research comes out and as there's more clinical proof that validates this mechanism of action, right, which is playing on the various receptors of these cells, whether it's the CD44 receptor for osteopontin or whether it's the TGF-beta receptor for SCUB3. But while we're talking about injections and biologics, I just want to talk about some pretty exciting news that just came out recently regarding a company called, I think they're called Extré. I'll put them in the description below, but they just received FDA investigational new drug acceptance for an injectable biologic called Xtini, XVIE. I'm assuming it's Xtini, or whatever they want to call it. I'll just call it that. But it's derived from decellularized human amniotic fluid, and it contains a broad cocktail of growth factors, extracellular vesicles, and signaling proteins designed to potentially modulate the follicular microenvironment. So they're trying to make this standardized. It's like a more standardized PRP. It's big news because the FDA clearing an investigational new drug acceptance for this product goes beyond just Extré and Xtini because it establishes that injectable biologics targeting follicular signaling is a viable regulatory pathway for androgenetic alopecia. Another thing that's important to mention is that it's kind of on an accelerated pathway to approval. So all they need is a good phase 1 and phase 2, and essentially this product, Xtini, could be approved for clinical use, just straight up clinical use. It can be used now a bit off-label. It's in like this weird gray area where it still can be used, but if they want to go through a more formal drug route to become a widely accessible biologic, they need more clinical evidence, and this could help them reach that milestone. When we look at the direction of Amplifica and AMP-303, it seems to be that it's going to be a biologic, and if that's the case, it could be on the market sooner than we realize, right? If they have a good phase 1, which essentially they did have a good phase 1, if they have a good phase 2, a really large phase 2, it could be the case that you could see AMP-303 in clinics sometime, 4 years down the line, maybe 5 years down the line instead of 10 years down the line, right? I know it's the whole 5 years meme, but still, this seems to be shaping up pretty well. So yeah, once again, that interview that Dr. Maxim Plikus was in, very eye-opening. He even talks about it himself, right? It's about targeting the actual cells that matter, not the hair follicle stem cells. They're already there in the scalp, but we have to target the thing that is supposed to stimulate them and get them to transform into different cells that make up the hair follicle. And that would be getting the mesenchymal layer functioning properly to create better dermal papilla cells, or potentially creating a surrogate to what the dermal papilla cells would otherwise produce, right? So if you can get those growth factors and signaling factors that the dermal papilla would normally produce, that could possibly, again, be a surrogate to signaling to the hair follicle stem cells to properly differentiate. So in any case, guys, Amplifica could be the first therapy that does this. It's probably not going to be a maintenance drug. It's probably not going to be a drug that slows down hair loss. This could be a genuine regenerative therapy that is going to target the biological root of androgenetic alopecia and probably other forms of hair loss. Again, this is just my take, and it seems as if Amplifica is really, they're on their grind and they might come out with some news soon. So hopefully we can expect that. But anyway, guys, the pieces are coming together, and Amplifica is extremely well positioned to be at the front of that wave of hair follicle regeneration. So stay tuned, and thanks for watching this video. I hope to see you in the next one. Bye, guys.